If you want to find the area between two curves, such as this yellow region here, the first thing to do is find the points at which the curves intersect each other. So let's say they intersect each other at A and x equals B. Then what we're going to do is we're going to work out the integral of the top curve subtract the bottom curve. So the top curve is g of x in this case, because g of x is above f of x for this region. So we're going to do the integral of g of x subtract the bottom curve, which in this case is f of x. And our limits will be from A up to B, the points of intersection. The reason why this works is because we can split this up into two integrals. We can split this up into the integral from A up to B of g of x, subtract the integral of f of x. And this works because this first integral here is the area underneath g. So if we were to sketch that out, it would be the area like that. But we don't want this full area, so that would give you that area there underneath g. We don't want that full area. We need to subtract this area underneath f. So if we want to subtract that area underneath f, then we need to subtract this integral here. Which is shaded red in this diagram. So in this example, we're going to work out the area underneath f of x. So that would be the integral of f of x. And then we're going to subtract the area under g of x. But we can just write that as a single integral of f of x minus g of x. And normally you'd have to find the point at which they intersect each other, but that's been given to us in this question, and you can check that they do intersect each other when x equals 0 and x equals pi over 2. So now we're going to substitute in. So f of x is actually sine of 2x, and g of x is sine x cos squared x. So we've got two terms to integrate. Let's do them separately. So let's start with the integral of sine 2x. Well, we know that sine integrates to minus cos. So it's going to be minus cos of 2x. And we need to divide by 2. Because the derivative of 2x is 2. So it's going to be minus a half cos of 2x if you integrate that. You could also do a substitution. You could let u equal 2x and go through that process. We also need to integrate the second term. I'm going to leave the minus out of it. And I'm just going to work out what's the integral of sine x cos squared x. Okay, so this one might not be as obvious. I'm going to use a substitution. I'm going to let u be cos x. And the reason I'm doing that is because du by dx is going to be minus sine of x. So I've spotted that sine is related to the derivative of cos. So if I rearrange this, I know that I'm going to divide by that derivative because dx is equal to minus 1 over sine x du. So the integral becomes the integral of sine x, let's leave that as it is, cos squared x is u squared, and then we're going to replace dx with this expression here. So minus 1 over sine x du. So the reason why we did that substitution is because I knew that when I divide by the derivative of cos x, we're going to cancel with the sine. So now we've just got to integrate minus u squared, and the integral of that is going to be minus a third u to the power of 3. But u is cos x, so we've got minus a third cos cubed x. Now we've got to be really careful here because I ignored this negative here when I did this integral. So when we go to square brackets and when we integrate this, I'm going to have the integral of sine 2x, which we worked out was minus a half cos 2x. And then I'm going to use that minus in the red circle there. And then I need to subtract the integral of sine x cos squared x, which was minus a third cos cubed x. And then we need to sub in the limits from 0 up to pi over 2. So I haven't written it out, but really what we've done here is we split that up into the integral of sine 2x minus the integral of sine x cos squared x. So that's why I've got minus minus, because this integral had a minus in front of it. So I'm just going to neaten this up a little bit and write that as minus a half cos 2x, and I'm going to write that as plus a third cos cubed x. So let's sub in the top limit. If we sub in the top limit, we're going to have minus a half cos of 2x, but x is the top limit is pi over 2, so cos of pi, plus a third cos cubed of pi over 2. And then we need to subtract the lower limit. Sub in the lower limit, we're going to have minus a half cos of 0 plus a third cos cubed of 0. Well, cos of pi is minus 1, so we're going to have minus a half times minus 1, which is plus a half. Cos of pi over 2 is 0, so this term is 0. And then we're going to have minus cos of 0 is 1, so we're going to have minus a half times 1, which is minus a half, and a third times 1 is plus a third. So we're going to have a half, plus a half, and plus a third. Sorry, minus a third. If we expand that bracket out, so we're going to have 2/3 as our answer.